Welcome viewers. In this video we'll see the capacitor start induction motor that is coming under single phase induction motor. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic capacitor start induction motor. We know that induction motor is not a self-starting motor. By making arrangement we can make it a self-starting. The first one is we have to design with the two-phase winding. Single phase induction motor is converted into two-phase, and the second thing is the current flowing through these two phases should have a phase difference. Then only the revolving magnetic field will be generated. Due to that, the motor will become a self-starting. Now we'll see how it is possible. First consider, suppose if it is only one winding is available, then the current flowing through the winding is alternating in nature. So this is a current flowing through the single winding if it is single winding. So due to alternating nature, the flux is also produced in a alternating. During positive off cycle, positive flux is produced. During negative off cycle, negative flux will be produced. So due to this positive off cycle, negative flux, positive flux, negative off cycle, negative flux, the total flux will be zero. So if the single winding is available, while passing the alternating current, alternating fluxes are produced, but due to positive and negative flux, the net flux is zero. So the revolving magnetic flux will not be created. So due to this, we are designed with the two phases. The single phase winding is converted into two phase. And another condition is in that two phase there should be a phase difference. For example, the current in the second winding should start after some time, approximately 90 degree. 90 degree phase difference should be there. So if it is after 90 degree, if it is started, what happens? See this, at this point the current is increasing, the flux also increases. At that time this flux is decreasing. So one flux is decreasing means another will increase. So the net flux will be created. Due to this phase difference, the net flux will be always generated. That is called a revolving magnetic flux, RMF. Right? So only one current, only one winding is there means net flux is zero. If the two windings are there with the phase difference means there should be always some flux will be produced. That is called a revolving magnetic flux. See this, at this point it is decreasing. So here it is start increasing. So one is decreasing means another one will increase. So there always some net flux will be produced. So there is a two condition. One is it should be two windings. Second one, current flowing through these two windings should have a phase difference. By making this, we can make the induction motor, single phase induction motor into self-starting. So based on that, this method is coming under capacitor start induction motor. We are using capacitor to make a phase difference between these two currents. Now see this diagram is a single phase induction motor. The supply is given, it's a rotor, rotating part. This is a stator. We have two windings called main winding and starting winding. During starting only this winding is used, so that is called a starting winding. Thereafter it is disconnected by using the centrifugal switch. So that is called a starting winding. This is main winding. So both the winding have the sum of the resistance are available. So main winding is having resistance. In order to make this phase difference, the capacitor is connected in the starting winding. Apart from resistor, capacitor also available. We know that the nature of the capacitor is it will lead the current. Current is lead. The voltage available means the current will lead the voltage. That is the nature of the capacitor. Now we'll refer this diagram, phasor diagram. The voltage is taken as a reference. We have two current, main current and starting current, IM and IS. See this IS, starting current, is having the capacitor. So it will lead the voltage. It will lead the voltage within the angle between this starting current and the main winding current is alpha. Right? So because of capacitor, the current flowing through the starting winding IS lead the voltage. but this main winding IM current having only resistor and also reactance will be there, inductive effect. So it is lagging by the IM is lagging the applied voltage with an angle of pi m. Then angle of pi m will be there. So the sum of these two, IS and IM, is vector sum is nothing but total current. That angle is pi. The angle between I and V is pi. Right? So because of capacitor, automatically we are getting some phase difference between the main winding current and starting winding current with an angle of alpha. That is our condition. First condition is two phase. So we are having two phase, main winding and starting winding. And phase difference. The phase difference is done by the capacitor. Right? Due to capacitor effect, one current, starting current is leading, another current is lagging. So there is a phase difference between starting current and main current, alpha. So due to that, there is a rotating magnetic field will be produced. So it will have the torque also produced. So it will start rotating. Once it is rotated, after some time, due to the centrifugal switch is there. Due to centrifugal action, the switch is open. So this winding is disconnected. So this winding used only for starting purpose. After starting, based on the centrifugal action, it is disconnected. So that it is called a capacitor start induction motor. And one more type is there, capacitor start, capacitor run. During running also capacitor is connected. But here capacitor connected only during the starting time. Now we'll see the description. What we discussed, the description available. So similar to split phase motor. What is split phase motor? This separate video available. The phase is splitted. The single winding is splitted into two winding. There also there is some phase difference because of reactance effect. Here also during starting period, single phase motor is converted into two phase motor. That is starting winding and running winding. The phase difference between the starting winding and main winding current is achieved by connecting a capacitor in series with the starting winding. Right? So this capacitor will make a phase difference between starting winding current and main winding current. And I will see further. The current IM drawn by the main winding lags the applied voltage. We already discussed. This IM is lagging. The current IS drawn by the starting winding lead the applied voltage because of capacitor is connected. So IM is lagging, IS is leading. Therefore, starting torque TST is proportional to the sine of phase angle between IM and IS, that is alpha. Starting torque developed by the capacitor start induction motor is high. So the another method is low, but here it is very high. The capacitor and starting windings are disconnected from the motor circuit after the motor has reached the nominal speed by means of centrifugal switch that we already discussed. So what are the applications of this motor? It is used in the pump, compressor, conveyor, machine tool, etc. I will see the torque speed characteristics of this capacitor start single phase induction motor. So this is speed torque characteristics available. So the torque speed characteristics, this x-axis speed is there, and y-axis torque is available. This is the zero speed, the starting torque. This is the starting torque. It is drawn by the two different motors. Capacitor start induction motor. What is we are discussing? Capacitor start, capacitor run induction motor. That is the next type. Separate video available. For that also we are having the speed torque characteristics. So what is that? Initially the torque is when the speed increases, the torque is keep on increases and reaches the maximum value. After that start decreasing and reaches some steady state value. It is approximately 150% of the full load torque. In these two methods, this capacitor start having more torque, high torque. Then the capacitor start, capacitor run is having low value. This is less than the First method, capacitor start induction motor having high value. This method, this type is having lesser value of torque, right? So it is increasing, reaches maximum value and got the steady state called a starting torque. So in this video we discuss capacitor start induction motor. How we are making the induction single phase induction motor into self starting. There are two conditions. One is it should be converted into two windings. The current flowing through these two windings should have phase difference. In this method it is splitted into two windings and the phase difference is done by the capacitor connected in series with the starting winding. So due to that, rotating magnetic flux is produced, so that torque is developed, motor start rotating. After certain speed, it will, due to the centrifugal switch action, the centrifugal switch is open and the starting winding is disconnected. So that is called a capacitor start induction motor. Another type, capacitor start, capacitor run, separate video available. And we discuss the application and torque, speed torque characteristics. So this method having more starting torque, more value, other method having less value. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. All the best for your examination.